Alright, next part. Let's look at some examples from the homework. Looking at question number 8, it talks about polonium. Polonium-210 is a radioactive isotope that has a half-life of 20 days. Suppose you start with a 40 milligram sample. Create a table of values that gives you the amount of polonium-210 remaining at the end of 5 intervals of 20 days each. Let's start with 20 days. 0 days. At 0 days, the initial value, has 40 grams. You go 20 days later, and you have half as much. You go 20 days later after that, you have half of the previous half. The next day, you have half of the previous day. And the last day, you have half of the previous day to that one. Now, let's do one more. Let's go up to 100. Half of 2.5 is 1.25. So you have 1.25 grams of polonium after 100 days. So, write an equation in the form y equals f at x equals ab to the power of x that relates the amount of polonium to what's happening. So, to do that, we have f at x is equal to ab to the x. So we need to find out what a and b are. F at x is equal to a turns out to be the first letter in the alphabet and the first part that everyone is willing to touch, but the first part has very important feature. The A stands for the first letter in the alphabet. In our case, the A is going to be how much we started with, then the zero value. Zero value is 40. Next part, you're going to multiply it by a half, because in order to get the next number, we needed to half everything. So half to the power of x over 20. Why is it x over 20? Because, folks, we don't go to sleep and wake up and it's 20 days later. We operate by days. So, x over 20 is just saying forever how many numbers we're looking at divided by 20, because 20 was every 20 days is the half life. So f at x is the amount of product left after x days. X is the number of days that have passed. X over 20 will determine the half-life that has passed. So you have your equation, and you're asked the following. Okay, and don't forget that there's an x here, and we sub in part D. If we're looking at D, D says how much polonium-210 will remain after 10 weeks. Well, we can see that after 10 weeks, we will have, well, to do 10 weeks, remember it's weeks, we need days. Take 10 times 7, because there are 7 days in a week, and that is equal to 70. Plug it into the equation so that you get f at 70 is equal to 40 times 1/2 to the power of 70 over 20. This is the reason why I want you to get a funky duty, folks. Look at the calculator. It gives us the answer we're looking for. 40 times 1/2 to the power of 70 over 20. I can type that exactly as it is in the calculator, and it will spit me back an answer. The answer here is 3.5355 grams are left after 10 weeks. Grams, in this case, is very, very, very tiny compared to the 40 that we started with. All right, E. F at x is equal to 40 times x to the 40 times 1/2 to the power of x over 20. What does E say? E wants us to determine how long it will take for the amount of polonium-210 to decay to 8% of its original mass. Let's go back to that other question. So we get f at x is equal to 40 to the half x over 20. Well, this is going to equal 8% of its original value. 8% of its original value is equal to 40 times blah blah. So what happens here is that the 40s can cancel each other out, or you can take this and divide it by 40. Ultimately, you will get the right answer and the same answer as I just described. And you will have 40 times 1/2 to the power of x over 20 is equal to 3.2. Now, I'm going to introduce a concept called log. What is log? That's what a lot of students are definitely afraid of. You will learn log in grade 12. So I'm going to leave it to your grade 12 teachers. In order to understand it at the grade 11 level, the goal is if you ever need to find a value where it's not as easy, you will need to come and find me to be able to understand how to do questions, for example, like this. Do not come on the day of the test. 3.2, we divide it by 40 reverse bed mass, folks. And once we do that, we can then apply the square root. Not the square root. We're going to apply something called logarithms. Log of the base and 2 over 25. So log of 2 over 25 is equal to, divided by log of the base, is equal to x over 20. That is true always. The exponent becomes your answer. Log of this divided by log of the base that we're trying to find. You're always going to do it that way. All right. The answer to this, once you type it in your calculator, is going to be 72.8771 days. All right, question number 9. It talks about the velocity is 13,500, which is the original amount that the product is worth. Then you're going to look at a decrease percentage. How much do you lose on the car? Well, as soon as you drive it off the lot, you start losing. Okay, now let's look at the equation. The 13,500 means that it was the original price of the motorcycle. The 0.8 implies that there's a decrease. Why is there a decrease? Well, think about it. The product went down 20%. When you start with something, you start with 100% of an item, right? Well, if you decrease by 20%, means that you have 80% left of your particular product. So to do that, we need to convert that 80% to a decimal. 80% as a decimal is equal to 0.8. And that T represents the time in years. Now, how do we know it's a decay, folks? Well, it's a decay because the base is between 0 and 1. The value of the base is between 0 and 1. As long as there are no other negatives lying around that might change things, and we will learn why in a little while, as long as there are no negatives lying around, if the base is between 0 and 1, we will have always a decay. All right, now, 9D asks the questions. When will it decay to 50% of its original value? Well, 50% of its original value means that it will be We take the equation. Now look at this, folks. This 13,500 can divide by this 13,500 so that you're left with just 0.5. 0.5 is equal to the function, and you need to find the value of t. Well, folks, take the log. Log of 0.5 divided by log of the base is equal to t. T is equal to 3.1063 years. Can you imagine trying to plug in values until you got that answer? That's why we use logarithms. All right, that's the end of the lesson, folks. Have a good day. Take care.